All right, today we are going to talk about translating figures and using vectors. So first, let's talk about what is a translation. We could use the vector notation, bless you, that we'll talk about to show it. But in general, what is a translation? What does it do?
Every vertex of the figure the same distance and the same
Good. It moves a figure. So a translation is an operation that moves a figure. You could put the formal definition if you want to, but it's about moving, or you could say sliding. Some people that refer to translations as slides, because it just shifts it up, down, left, right. It just moves it along. Okay, if you use the formal definition that we talked about yesterday, that's fine. If we translate point A, which is at 3, 5, 4 units right and 2 units down, what are the coordinates of the image? Good, so 7 units to the right, we're moving along the x-axis. Right is a positive direction for us. So 3 plus 4 gives us 7. 2 units down, up and down is the y-axis. Down, of course, means we subtract 2 from our y-coordinate, and we get 3. And yesterday we talked about denoting that with the prime notation, if you want to put that in there. Find the length of BC with endpoints -3, 5, and 1, 2. How do we find the length of a segment? John?
X2 minus x1 squared plus y2 minus y1 squared.
Oop, put another x. Yes, y2 minus y1. So if you would rather put your ones first, like x1 minus x2 and then y1 minus y2, that's the same thing. It doesn't really matter which order they go in as long as you are consistent. So that is our distance formula. When we plug stuff into that, what's the first x you want to plug in? -3 minus 1. That gets squared. Plus, if we started with -3, what y do we have to start with? Good. 5 minus 2. That gets squared. What is -3 minus 1? And if we square that? 16. Plus 5 minus 2 is 3. Squared is 9. Add them together, we get, and the square root of 25 is? Beautiful. Questions about number 3? On to number 4. If you translate the points M and N by using x, y goes to x minus 3, y plus 6, what is the distance from M prime to N prime? Now, this question is a little tricky because you could make it really long if you wanted to, right? We could find M prime and N prime, and then after we find those, then we could use the distance formula. But if we are just shifting or translating this segment, what's true about the distance between M and N and the distance between M prime and N prime? What should be true about the distances between 2 points if we're shifting it over? The distance is going to be the same. So do we need to find our new points? No. Does this thought process make sense?
Yes.
You don't need to know what the translation is. Any translation you do preserves distance between 2 points. So I can just find the distance between M and N, and that'll be the same thing as the distance between M prime and N prime. We have questions about that? Okay, I know that's one of those things where we just have to kind of think it through. There's really no work to show. Unless, of course, you want to find the new coordinates and then do the distance. So, if we do distance formula with these points, what are you plugging in first? 4 minus a negative, I'm going to write it as plus. And then for my y's, 7 minus 5 gets squared. 4 plus 1, square it. 25 plus 7 minus 5, 2 squared is, add them together. Can we take the square root of 29? No, it doesn't even simplify, so we are done. Questions, concerns? Yes, ma'am.
Wow, why you add first?
Because we were subtracting a negative. 4 minus a negative 1 is just adding. I'll tell you.
So this works with like everything. You don't have to find the new coordinates.
If you're finding distance for something that preserves distance, which all of these transformations do, then no, you don't technically have to.
Okay.
We could go through the process of finding the new coordinates and then doing distance, but we would end up with the same thing. Other questions, concerns? Okay, then we'll move into what we're doing today. Recall, this is from yesterday, a transformation moves or changes a figure in some way to produce a new figure. The new figure is called an image. All right, a note. Another name for the original figure is the pre-image. So you would start off with a pre-image, and then after a transformation, you get an image. A translation, we just mentioned this, moves every point of a figure the same distance in the same direction. So a transformation is, in general, anything that moves a figure. A translation is where we're just sliding it over, up, down, across, sideways, whatever. You're just sliding it around. The last definition on this slide, an isometry. Isometry is a transformation that preserves the length and angle measure. It's another word for a congruence transformation. Okay, and we should associate the prefix iso with same. Remember, an isosceles triangle has two of the same side. Iso should make us think same. So it's the same figure. All right, we are asked to graph the quadrilateral KLMN, given those vertices. Find the image of each vertex after the translation, which they give to us in what's called vector notation. Then graph the image using prime notation, which again, we talked about prime notation yesterday. So the point K, its image is going to be K prime. Same thing with L, M, and N prime. So I'll give you a moment to do this. I think we did this yesterday. You're probably familiar with it. Plot your original figure or the pre-image. Then do the translation that they give you. Plot your new image with the prime notation. And of course, your figures should be congruent. All right, who can give me the coordinates for K prime? Paris? -4 what? Good. -4, 0. That gives me K prime. So there is my K prime point. All right, what about L prime, Ari? 0, 5. is my L prime. 0, 5, L prime. Yanni, what about M prime? What is it? Do you mean a positive 1, comma 4?
Yeah.
Oh, good. Okay, so positive 1, 4 is going to be my M prime. Prime. And what about N prime, Akira? 2, comma 1. Sounds good for N prime. 2, 1. N prime. All right, and then of course we can connect, bless you, all of our primes. And we should be able to see that these figures are the same figure. It's just shifted up and to the left a little bit. Questions, concerns? Warm, fuzzy feelings?
What does that mean?
What is what?
What does that mean?
Warm, fuzzy feelings?
Yeah.
We feel good about something.
Oh.
We feel positive energy. We
Warm,
like
fuzzy
it.
feelings.
Warm, fuzzy feelings. All right, the image of the translation xy goes to x plus 4y minus 7 is p prime q prime with endpoints p prime at -3, 4, q prime at 2, 1. Find the coordinates of the endpoints of the pre-image. So this is a little different from what we did yesterday. Yesterday we always knew where we were starting and we figured out where we ended, just like on example 1. This one goes backwards. We know where we ended up. We know how we got there. We're trying to figure out where we started from. Does this make sense? Kobe, do you have an idea? Oh, I thought you were raising your hand. Not raising your hand. Detriana?
I had -7, 11.
How'd you get -7, 11?
I added yeah.
Is that for P?
Yeah.
Okay.
I thought about what would go into what could you use that goes to -3? I can't explain it now.
I think you have the right idea. So we're kind of working backwards. So if we are trying to find x, if x plus 4 came out to be a -3, right? We're trying to figure out what the x coordinate is if x plus 4 is -3. This is for point P, of course. Does this make sense? So how would we solve this, Kobe? So we would subtract the 4 on both sides, and that x coordinate, like Detriana said, is -7. So for P, we know -7 is our x coordinate. All right, Kobe, what would we set up to find y for P? Yes, we would end up adding 7. So if we're trying to find y, if y minus 7 came out to be 4, then yes, we would add the 7 on both sides, and we would get that the y coordinate is 11. Are we done with this problem? Why not? Okay, we still have to find q. So q is going to be the same idea. We're trying to find x if x plus 4 equals what? What was the x coordinate of q prime? 2. So how would we solve it? Subtract the 4, x equals -2. So for q, my x coordinate's -2, but I still need to find the y. So we're going to find y if y minus 7 equals what? Y minus 7 gets set equal to 1, and then yes, when we add the 7, y does equal 8. Taylor.
Do we have to write out those equations for the tester quiz?
Yes, I need to see where you're getting this from. So you don't have to put like the X if or Y if part, right? You don't have to put that. But yes, I do want to see your equations. You don't have to put, I'll highlight things you don't have to put. You don't have to put the X or Y if. You don't have to put the -4 or +7. Like those are Algebra 1 skills. I do want to see your equations though of how you're coming up with these answers. Okay? Other questions? Caleb, I thought I saw your hand up.
I was just gonna see if we could like kind of just change it like in the question or whatever, just like.
I want to see your equations. I want to see your work. If you happen to work backwards and you show it to me a little bit differently, that's fine, but I should see some sort of work written out. Questions, concerns? Yes. How is what? Mm-hmm. So we had to use the same translation that they gave us up here for both of P and Q. Does that make sense? Okay. Anything else? Ready to flip over? Okay, on we go. Write a rule for the translation of triangle ABC2, triangle A prime B prime C prime. And then, after that, write a rule for triangle A prime B prime C prime 2, triangle ABC. So we always know that we're going to start off, if we're writing a rule for translations, of X, comma, Y, arrow. Okay, that's how we say X, Y are going to this new place. And of course we'll have X, something will happen to it, comma, Y, something will happen to it. It's up to us to figure out what happens to those coordinates. You get to choose if you want to start at A, B, or C, or A prime, B prime, C prime. Now, if they're going from ABC to A prime, B prime, C prime, what triangle do you need to start with? ABC. Okay, so you pick a point, A, B, or C. Which one do you want to talk about? Okay, I heard B first. So if you want to look at A, that's fine. That's kind of a hard point to look at, in my opinion. See how it ends up in the middle of a box? Okay, I like using point B because it meets at those crosshairs. Does that make sense? We definitely could know the coordinates of point B. Do we understand why I like B better than A or C? Okay. So, what's happening to our X coordinate? Which way are we moving? To the right 1.5, right? Okay, we're not quite all the way over 2. Do we see that?
That's 3.
It is going to be 2.
How is it 3.5? It goes by 2.
Okay, we're counting by 2, so these are good things to notice. So yes, going this far would be 2, and then if we go halfway to 4, we're at 3. Does that make sense? We have to pay attention to our scale down here. Are we good with that? We moved to the right 3, so to X, what should I do? Plus 3. We all okay with X plus 3?
Yes.
Wonderful. All right, then we have to figure out where we go with the Y coordinate. So along the Y axis, where are we going? Down how many? 4, right? 2 boxes. If I've got a scale of 2, that means we moved down 4. So behind the Y, I should put
4 minus.
Very good, John. -4. Don't just put a 4. Probably won't get points for that. Questions, concerns about this? Okay, now to do the reverse direction should be really easy. What's the only thing you really need to do? Swap your signs. Okay, so instead of going right and down, now we're going backwards. So we're going left and up. But we still have X, comma, Y, arrow. Now it's going to be X -3 and Y +4. Questions, concerns?
Warm fuzzy feeling.
Yanni has warm, fuzzy feelings. Anybody else?
No.
Oh, dear. Are we ready to keep going? Sure, why not? All right, a new definition. A vector is a quantity that has both direction and, anybody seen Despicable Me? Magnitude. Both direction and magnitude. Or size. Instead of calling it magnitude, you could call it size. It is represented in a coordinate plane by an arrow drawn from one point to another. Anybody in here interested in taking physics at some point in their life? You will talk about vectors a lot in physics. Okay? You'll see vectors all over the place in physics, whether you take it in high school or in college. Are we ready to keep going?
Complicated stuff.
It's not so bad. Okay. All right, the diagram shows a vector named. Now, vectors and lines look similar. Remember, we use this to talk about rays also. But you will see this notation used for vectors. So we would read that vector AB. It's a little hard to see on this diagram, but there is an arrow at the top of this by B. Can we see that on the paper? Okay. So there is an arrow there. So this does look like a ray. Remember in chapter 1 we talked about rays. It has an end point at one side, an arrow at the other. Okay, it's the same looking shape. Okay? All right, so I might use different words than your book is going to in this, but we can add more to it. So the initial point, I feel like there's another term for that. We'll look in your book for a minute. The initial point or starting point of the vector is A. The terminating point or ending point is B. Okay, the component form of a vector, combines with vertical and horizontal and vertical components. So, the component form of vector AB, sometimes you'll see it written with these. It almost looks like an inequality symbol or an arrow. Okay, instead of just using parentheses around a coordinate, we use this little arrows instead. Okay, and if we're moving 5 units right, would that be a positive 5 or a negative 5? Positive 5. And if we're moving 3 units up, that would be positive 3. So this is the same as having the coordinate notation x plus 5 comma y plus 3. They just shorten it up. Are we all okay with that? So they're just shortening it up for vector form, for component form. Questions, concerns? So we're saying we're taking this initial point and it's going to terminate after we move it up 5. Sorry, after we move it right 5, up 3. It's just a different way of writing it. Questions, concerns? Okay, again, we can look in your book in a little bit if we are really curious about the different words that we could use to talk about those. Starting and ending are really what you need to know, realistically, right? It starts here, it ends here. Okay. Name the vector, write its component form. So when we name it, it's just how we would talk about it. So how would we name this first vector? Okay, we would call it vector AB. Yes, it is the same form as array. So vector AB, that means that we start at which point? A, and we end at B. So if we're writing its component form, we know we're going to have those little arrow brackets around it. First, we talk about its direction horizontally or along the x-axis. Which way is it going? Remember, horizontal would be left or right. So to get from A to B, we're going right. How many units? Okay, so 1, 2, 3, 4, 5, 6, 8. So 1, 2, 3, 4, 5, 6, 7. There we go, all the way over. So if we're going right 7, what number should I put first?
7.
A positive 7. And then where are we going?
Down 5.
Down 5.
That's a negative 5.
So that's a negative 5. Okay, when you do this later on in your potential future physics class, you'll often see both of these vectors drawn, like with arrows. You'll see the horizontal vector and the vertical vector both drawn. You don't have to put them in there, just showing you a little something extra. Are we okay with the component form? Yes. Okay. For part B, what is the name of that vector? Vector RS. Remember, we got to start at the point, end at the arrow. For our component form here, which direction are we moving horizontally?
No, left.
Left. We start at R. We got to start at the point, end at the arrow. So we would have to move to the left.
Oh my God, I don't know my left and right. What?
That is an issue for these. Okay, so we went left 4, so negative 4. Then we went up 4, so that's a positive 4. Okay, this is really nothing different from things we've already done. It's just writing it a slightly different way. Questions, concerns? Ready to keep going? Yeah. Okay. The vertices of triangle DEF are given to us. Translate triangle DEF using the vector 2, negative 3. Verify the translation is an isometry. So let's focus on translating it first, and then we'll talk about how we could verify that it's an isometry. It does not say that we need to graph the original figure, so for now I'm not going to worry about that. Let's first figure out our new vertices. So I'll call them D prime, E prime, F prime. What would the new vertices for D prime be? What is it, Kobe? Good, 0, negative 3. So remember, this is what we do to x. It's a positive 2, so we're adding 2. This is what we do to a y. A negative 3 means we subtract 3. What about E prime? 1, 0, and F prime? 4, negative 4. Are we all okay with getting our new vertices?
Yeah.
Okay, there are a couple different ways we could verify that this is an isometry. One way would be to do it visually, so we could graph our original. So negative 2, 0, negative 1, 3, and 2, negative 1. So that is my D, E, F. And then we could graph our translation. 0, negative 3, for D prime, 1, 0 for E prime, and 4, -4 for F prime. They overlap each other a little bit, but visually, do these look to be the same size and shape? Yeah, so visually we could verify that's an isometry. What other way could we verify that it's an isometry? How could we show that DE and D prime E prime are congruent to each other? Okay, we can find their distances. Now, that's going to be a little time consuming because how many distances would we have to calculate altogether? 6 of them, right? 3 for each one. So unless it says verify using the distance formula or something like that, if it just says verify and it gives you a graph, I'm fine with visually verifying. Okay, most of you, I believe, would be able to notice that if you got one triangle that was small like DEF and then you got another one that was like really big or had a completely different shape, you would be able to tell those are not going to be the same. Questions, concerns? Okay. Your homework, you do need to write down. Remember, there's not an assignment guide because we have such a short unit. So we are on page 576. Numbers 1, 4 through 12 evens, 13, 14 through 26 evens, and 31. So I would write this down. There's a space to write it at the bottom of your notes.